Okay, so we are looking at section 7.6, which is called Dilations and Similarity in the Coordinate Plane. Everyone has their notes out? The objectives in this section are to apply similarity properties in the coordinate plane and use coordinate proof to prove that figures are similar. Your vocabulary for this section are dilation and scale factor. So let's take a look at this example. Many photographs on the web are in JPEG format, which is short for Joint Photographic Experts Group. Who knew? I didn't. When you drag a corner of a JPEG image in order to enlarge it or reduce it, the underlying program uses coordinates and similarity to change the image's size. And just so you know, I can do the same thing. I don't think this is JPEG, but I can take a screenshot, let's say, of this picture right here, I think. And notice what happens. When I drag this, it's creating a similar image because it's keeping the ratio of the length to the width the same. Does that make sense? So that's the same thing that they're talking about here. Ken? You did? That's great.
Good job, Kenny.
Joint Photographic Experts Group.
Yeah, it was in my job.
Awesome. I did not know that, so I learned something. Okay. All right, so a dilation is a transformation that changes the size of a figure but not its shape. All right, the pre-image and the image are always similar. A scale factor describes how much the figure is enlarged or reduced. For a dilation with scale factor k, you can find the image of a point by multiplying each coordinate by k. So in other words, we would take some ordered pair AB and multiply it by k and get KA, comma, KB. You okay? Okay, so we're looking. What's wrong? Stop, please. Dilation is a transformation that changes the size of a figure but not its shape. Is that on your tool belt? Yes? And a scale factor on your tool belt? Yes? All right. So moving on. Let's take a look at this example. It's a computer graphics application. Draw the border of the photo after a dilation with a scale factor of 5/2, 5/2. So what would be the current ordered pairs that we have here? Jacob, what ordered pairs do we have here? Jacob, what order pair is this right here? 0, 0. What's this order pair here? This is a tick mark, tick mark, tick mark, tick mark 5. 3, 0. How about this one right here? 4, 0 would be over here. So what's this one? 0, 4, and then this one's going to be what? This is 3 over, and how far up? Same height as this one. 3, 4. Okay, so now you're going to take each one of those ordered pairs, and you are going to use the dilation with the scale factor of 5/2. So what ordered pairs? I'm going to give you about 30 seconds to write down what these new 4 ordered pairs are going to be once we have that. What are we doing? We're taking every ordered pair where our dilation is x, y is going to 5/2 x, comma, 5/2 y. Agreed? Does that make sense? Take every ordered pair and multiply by 5/2. So give me an ordered pair here, Ken.
That being 0, 0.
0, 0 still going to be 0, 0?
Yes.
All right, that one's not going to change. That's still going to be right here. What's another ordered pair? Ken got the easy one. Vince.
For B, be 0.
You got to take 5 halves times 0, which is 0, and then 5 halves times 4, which is going to be what? 10, all right? So we need 0, 10, wherever that is, up here, let's say.
Take it a little higher.
Can't reach any higher. All right, and then what other ordered pair? Andrew?
C, 7.5, 0.
Down here?
Yeah.
All right, so taking 3 times 5 halves, that's going to be 15 over 2, 7.5. So this is going to be 7.5, comma 0, which I'm going to actually have, let's see, 5, 6, 7, like somewhere around here. Everybody agree?
Came a little closer to this.
You're going to be very precise, Bill, I know, on your homework when you use graph paper to do the assignment. You're going to be very precise. And then what about our last remaining ordered pair is going to be where? Kevin. So in other words, I'll call this point A prime. This point is B prime. This point is C prime. So what's D prime going to be? Instead of, oh, I'm sorry, this is D prime. So what's C prime going to be? 7.5 over and 10 up. Do people agree? All right, so that's how you do this. And that's what they're telling us here, our answers. Okay, so let's take a look at this example. Given the triangle TUO, there it is, TUO, is similar to triangle RSO, can you find the coordinates of point U and the scale factor? And what segments are going to be proportional in this picture? What segments are going to be proportional? For example, if I say segment TO is to segment RO as what is to what? Can you fill in the missing right side of this, Bill?
OU is to OY.
That's a point S.
That's
This is
Oh.
the y-axis.
Okay. OU is to OX.
All right. Thanks, Bill. Okay. 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 So now that we have these lengths, can you fill in the sides here? I'm going to pause for 30 seconds while you get this example copied down in your notes. You're drawing triangle TUO with T at -9, 0, and you're going to draw triangle RSO where R is at -12, 0, and S is at 0, 16. And I'm asking you to fill in the side lengths in this picture.
So, Amy, I heard you on the answer. Got you. Okay.
What are we filling in here, Catherine? What is the length of TO going to be? This length right here. Well, this is the point -9, so its length would be 9, right?
Yep.
9 units. So TO is 9, so I get 9 over what equals what over what? What else can we fill in here, Riley? is what? All right, so we got 9 is to 12 as what is to what? What about the right side? Hunter.
X over 16.
Oh, okay, so you're calling this x because we don't know what it is, this length. All right, this length you're calling x, and you're saying this length here to here is 16. Everybody agree? All right, calculators, work this out. What's x going to be? All right, when you cross multiply and solve, you get what as your answer? Jessica. X equals what? 12. Do people agree? All right, so that means if the x is equal to 12, we are looking for the coordinates of point U. So this point right here has what ordered pair? What ordered pair would that be, Gina? What comma what? 0 comma 12. Do people agree? Yes? Is that okay? And we also want to know the scale factor. So what is the scale factor from triangle TUO, which is the small triangle, to triangle RSO, which is the large triangle? Tom, scale factor? Well, to get the scale factor, you're going to want to just reduce the ratios that we have, because we're saying TO is to RO, right? So the 9 over 12 reduces to what? 3 over 4. Do people agree? So the scale factor from the one triangle to the other? 3 over 4? What's my answer say? 3 over 4. Are we okay with this? Yes, the scale factor would be 3 over 4. All right. Okay, for this one, I'm not going to ask you to do this problem. I just want you to look and listen as we talk about this one. In this one, we are proving that these two triangles in the picture, triangle ABC and triangle ADE, are similar. We want to prove they're similar. All right, and their step 1 is to plot the points and draw the triangles, so that's already done. Step 2, use distance formula to find the side lengths. So if I use distance formula to find the length of AB, I'm going from 1, 5, it looks like, is A, to negative 1, 3, and that turns out to be square root of 8. The length of AC turns out to be square root of 5. The length of AD turns out to be square root of 32, which is 4 times square root of 2, and the length of AE turns out to be 2 times the square root of 5. So what you should hopefully notice here is that the similarity ratio AB is to AD, that's 2 rad 2 over 4 rad 2, that's 2 over 4, which is 1/2. And same thing with the similarity ratio for AC to AE. Square root of 5 over 2 times square root of 5 is 1/2. And don't forget that angle A is congruent to itself by the reflexive property. And so these two triangles are similar by SAS similarity. Are we okay with this? Does that make sense? Okay. Skipping. Okay. So I think I'm going to stop at this point. I'm going to give you the worksheet to do, and I think that we may, at the end of class, do a little bit of start our review for the Chapter 7 test.
Can we look at the